You'll find in this Mod 8 Unit 2 that we do a variety of different things that kind of get put together in one unit. And we're moving on from looking at functions into solving equations with absolute values. Well, at least we did look at absolute values in the last lesson, but these are not functions. These are just equations with one unknown. All right, solving an equation in the form absolute value of anything involving x is equal to a constant a. If a is positive, then the absolute value of x equal to a is either x is equal to a or x is equal to negative a. Let me see if I can explain that a little bit, and then we'll look at how we use this concept to solve equations. If I have the absolute value of x is equal to 2, well, there are two different solutions to this. Think about what could be in the place of x. Well, the absolute value of 2 is 2, but the absolute value of negative 2 is also 2. So, the absolute value of 2 is 2, the absolute value of negative 2 is 2. That's not showing you how to solve it. That's just letting you know that it makes some sense that what is in here either takes on the value of 2 or it takes on the value of negative 2. So, to solve an absolute value, if you had the absolute value of x is equal to 5, then x is either 5 or x might be negative 5. If there was something to solve, you would. As it is, you've got two answers. If instead you had the absolute value of x plus 3 is equal to 8, then you could say that the quantity x plus 3 might be 8 because the absolute value of 8 is 8, or x plus 3, which is inside, might be negative 8 because the absolute value of negative 8 would be 8. You have two equations, you solve both of them. This one, subtract 3, x could be 5, or subtract 3, x could be negative 11. Now you could check those. 5 plus 3 is 8, the absolute value of 8 is 8. That one checks. Negative 5. Negative 5 plus 3 is negative 8. The absolute value of negative 8 is 8. That one checks. I think in Math Lab it will probably have you separate the answers with a comma. So let's go see what our problems look like. Problem number 1. It says solve the absolute value equation. The absolute value of x is 15. All right. What we're going to do every time, whoops, a little bit of the book came up. Get myself a little more room. We're going to take that absolute value. Now, it needs to be isolated all by itself. If there was anything else added or subtracted over here, I would get it to the other side. The absolute value of x is 15. That means the quantity inside is either equal to 15. Let me rewrite that a little neater. So x is 15 or x is negative 15. There's nothing to solve, so I just have two answers. Here it says use a comma to separate answers as needed. So inside that box, it does not matter about the order. You will have 15 and negative 15. We'll look at one in a few minutes where the solution set is the empty set. All right, the next one, it says the absolute value of 2x minus 7 is 9. That means that 2x minus 7 could be the value 9, or the 2x minus 7 could be the value negative 9. Solve each one. Add 7. So 2x is 16. Divide by 2. X is 8, or add 7 add 7. 2x is negative 2. Divide by 2. X is negative 1. So my values are 8 and negative 1. Let's look at number 3. I have the absolute value of x plus an 8 is 32. I cannot use this statement right here. I cannot use this statement unless the absolute value is all alone. So in this problem, I need to subtract 8 first. So then I have the absolute value of x is 14. Whoops, creative subtraction. How about 24? Now I can use my two statements. That means that x is 24, because that's what's inside, or x is negative 24. You're taking what's in the absolute value and putting it for both of these choices. You're setting it equal to the positive and the negative of that. There's nothing more to do in this problem. Our two answers are 24, negative 24. Let's look at number 4. It has the absolute value of 7x plus a 10 is 17. I cannot look at the two cases until I isolate the absolute value, so subtract 10. That means the absolute value of 7x is equal to 7. Now I can look at the two cases. In one of them, 7x could be 7, or 7x could be negative 7. You take what's inside the absolute value, you set it equal to the positive and the negative. The first one, divide by 7, x could be 1. The second one, divide by 7, or x could be negative 1. My two answers are 1 and negative 1. It doesn't matter about the order. Okay. Now I've been getting two answers. This is the only scenario, absolute value of something equals 0. This is the only scenario where I'm only going to get one answer, because 9z equal to positive 0 or 9z equal to the opposite of 0, that doesn't make sense because there is no such thing as negative 0. So you only have one scenario, divide by 9, and z is 0. So we only have one answer. That's the only time when the constant that it's equal to is 0. All right, this one, I have the absolute value of 2n plus 9 plus 11 is equal to 8. All right, I have to isolate the absolute value, so I'm going to subtract 11 from both sides. That means that the absolute value of 2n plus 9 is equal to negative 3. Now, I'm going to stop because the statement that I had at the very beginning, going back, says if a is a positive number. The absolute value of x cannot equal a negative. It just can't. So, since I've isolated the absolute value and it's equal to a negative, this is an impossible situation. There is no solution. And this symbol is an empty set symbol. So the solution set is the empty set, meaning no solution. So if you get your absolute value isolated, no matter what it is, if it's an absolute value isolated and it's equal to a negative, stop the problem. There is no solution. It is called an empty set. All right, work on those absolute value equations.